Well, it's very nice to be able to speak after Martin and Stuart, so thanks very much for that. And it's thanks to Martin. I've started already. Thanks to Martin for some of your slides. I think I can skip some of mine, and Martin's introduced a lot of stuff that I want to talk about, and thanks to Stuart for his very interesting presentation and for mentioning suits, because you'll see that Stuart and I use the same tailor. But look, yeah, I think, great, we're ready to go. So look, I'm wanting to change and talk a little bit more now about energy systems, energy efficiency and policy to a certain extent. And I'm leaning very heavily here on work of my colleagues, and I have to also apologise to my colleagues that in trying to give a snapshot, or in trying to give an overview of the work going on within our school, I've probably gone for more of a snapshot from my perspective. I've got a lot of slides from a lot of my colleagues, and I've included the ones that I understand. So I will keep going and give you a snapshot which has, I guess, more from my perspective, so apologies to my colleagues up front. So, but talking about PV, wind, metrology, solar thermal, buildings and efficiency is what I'm going to try and do, so I better get started because Darren's given me just a few more minutes. Look, a few years ago, you would have looked at something like this slide and seen mostly black or brown and maybe a little bit of blue, black being coal, brown being brown coal, and the states, I don't know if you can see that, but that's the national electricity market. A very nice widget. I hope most people have seen this. I tend to spend, just about every minute of the day checking out, seeing what's going on, but no, not really. But look, not so long ago, this slide had no solar on it. The yellow up the top there, particularly in New South Wales, this is a good day today, good solar day, and some green is the wind and the blue is the hydro. 90% of the electricity, when I started back in the mid-80s, I think about 90% of the electricity in New South Wales was coming from burning of black coal, and that number over my time in energy has gone down. And we're seeing, as Martin pointed out, since about 2005, things really started to kick off with photovoltaics from a manufacturing point of view, but from an implementation point of view, in the last 5 years or so, we've seen these distributed solar, particularly in Australia. Australia, 5 gigawatts of PV. 5 or so years ago, we had no gigawatts of PV. Essentially, if you rounded it to the nearest gigawatt, we've now got 5, and about 90% of that is on rooftops. So I want to talk to you about rooftops. A similar slide, I'm not sure if Martin had this one, but I think my next one's the same as Martin's. The falling price or falling cost of utility scale PV and wind. Australia, we've got some of the best solar and best wind resources, and so that's reflected in the low cost of the electricity. But an interesting point made by Ian McGill, a colleague of ours at a recent conference, was that if you look at the levelised cost of electricity for utility scale PV and in Australia for rooftop PV, despite the significant improvement in performance and output for the utility scale PV, rooftops have their issues. The overall performance and cost is quite comparable. So just as the price of PV is going down, the price of rooftop PV is going down in closely parallel. This one I can skip over, so thanks to Martin, I'll save some time. That'll be a little bit of brownie points with Darren. A recent study from CSIRO, and it's starting to find its way into the Herald. So I'm hoping into the newspapers. I'm hoping our political leaders and people who make decisions in this space are starting to, some of this stuff to filter through. It's all happened very quickly, which is probably why our political system is taking some time to react. But CSIRO put out an interesting report saying that up to half of Australia, of our electricity needs, could be powered off rooftops, people's own rooftops, commercial businesses, industry, etc. So there's the split, and there's lots of these different graphs, but I think PV, rooftop PV in this case, this was from the CSIRO report that's come out recently, is a big chunk. Larger scale solar, they're looking at slightly different mix there, but part of the reason for that is the financial benefit for customers, the benefit to the grid when we tackle those sorts of problems, and wind in here as well. Of course, the other thing that's happening is that it's always onwards and upwards. Our energy use is going up, although in more recent years, probably since 2008, we've seen electricity usage come down. So energy efficiency, of course, is something that we should be thinking about. And I thought I'd include this slide. This is the American Committee for an Energy Efficient Economy, anyway. It's an American-based organisation, and what they do, they used to just publish the energy efficiency performance of various states, or all the states in America. In more recent times, they've cast a wider net and started to put out a report card, an energy efficiency report card globally. And so you'll see that number one, I've got to look up there, the screen's too small. Number one is Germany. Number two is Japan. So there's the top two. America's up there at 8, the UK at 5, Australia we're at 16, so I think we're just ahead of Indonesia and just behind Turkey in terms of energy efficiency and going backwards. Buildings, all sorts of things are here. Buildings, industry and transportation. I'll talk more about buildings, just to mention transport along the way. Australia amongst the OECD countries, the 20 OECD countries that have been looked at. We're the only country now, I think, that has no transport requirements for no energy requirements or emission requirements on our vehicles. You can sell any old vehicle into Australia. We do not have any fuel efficiency requirements on vehicles, even though we do not have an indigenous car manufacturer. So we're facing lots of challenges, but there is good news, as Martin and Stuart have so well put forward. I want to also just add in this slide, which is from last year, which I apologise for, but just to point out the big chunks of, instead of seeing an ongoing and increasing CO2 emissions, can we also start to bring down those emissions, and what a big chunk of that can be coming from energy efficiency. To move on now to some of the work that we've been doing. So this is some work with Hua Fan, Ian McGill and myself, just looking at residential energy usage, which is a big chunk in the end of what happens in any country. This is for Greater Sydney, and this is just looking at peak demand. I'm not sure, hoping you've got good eyes so you can see, but one of the things that we focused on was looking at summer peaks. You'll notice this is winter 2012, summer, 2012, that's right, 2013, summer, and then into winter of 2013. A lot of energy getting used on average in households in winter, which we can talk about, but the big peaks turn up in summer. So that's something that we probably are all aware of, but it's interesting to look at the breakdown. This is Smart Grid, Smart Cities data that has ducted air conditioning, split systems and no air conditioning. All the households were surveyed so we can see not only their electricity usage, but the sorts of equipment that they have in their house. So just seeing that breakdown, we can see that the ducted aircon systems are the big drivers for peak demand. Here's peak demand in the summer. Oh, I see. My mouse doesn't work, does it? Right. Okay. So, hence the pointing. So you can see that big peak in the summer is for ducted air systems, and the split systems is the green, different air conditioning systems, and people without air conditioning systems are the red, so way down there. So we can see that they're where the culprits are and what's contributing into peak demand. And if we look and see differences between different groupings, we can see that ducted clothes dryers perhaps might be a surprise, but clothes dryers really turned up as being a strong driver for peak demand. I guess if you're locked into drying your clothes, then that's going to be something you have to do whether you've got a hot summer's day or not. Pool pumps, there I had to mention them. Pool pumps are also a big driver on peak as well as split systems. So So one of the questions that is starting to be asked now in Australia in terms of energy efficiency is the opportunity is now upon us to review the National Construction Code, the Building Code of Australia. So the sorts of questions that are being asked now in Australia is how do we improve our buildings? This peak demand that we're talking about, the energy demand that I showed back here, a lot of that is coming from having quite poor building stock in Australia, as probably many of our international visitors will tell us once they've stayed here over a winter and experienced the joys of Australian buildings. So should we be aiming for zero energy, passive solar, passive house, or maybe something else, a combination? Are air-air heat exchangers, which are commonly used for very airtight buildings in Europe, are they appropriate for Australia? We've moved on from fibro shacks. Hopefully we've gone through the McMansion period. Custom-built, architecturally built houses, well, maybe not for everyone, but the passive solar, the PV, zero energy rooftops. People might recognise this shot. Does anyone recognise that one? I think I heard someone say it. Tesla down the front row, yes. So Elon Musk, he's gone from electric vehicles to batteries to rooftop building integrated PV. He's trying to corner the market, I think, on all of these good technologies. But what is the answer for Australia? Batteries, what is that mix? So these are the sorts of questions that are very much open for discussion and very much on our research agenda. Working through the Cooperative, this is work that I'm involved with through the Cooperative Research Centre for Low Carbon Living. This is a house in Perth, 10-star house. We're having a very close look at it in terms of modelling and energy performance. Josh Byrne on the ABC. I won't bore you with the details, but basically he's trying to run the passive solar house. A very, no heating or cooling systems in his house. So on hot days, can his house stay cool? Here's 1, 2, 3, 4, 5, 6 days above 30 degrees in Fremantle in Perth, and there's the temperatures inside his house, getting up to around about sort of 27, 28 degrees. So the debate in Australia now on the passive side, should we have people living in houses that respond as best as they can to climate, or should we be looking at integrating, I think I meant to put in an air conditioning unit here. Air conditioning units are becoming cheaper and more effective. Photovoltaics on the roof is becoming cheaper and more effective. There's lots of interesting questions to be asked about where to for Australian housing. Another project that we're working on with CSIRO, looking at a very nice 8-star house out in Western Sydney. Even so, my student Zichao Meng, armed with his infrared camera, came along, and after the people had installed the insulation, along came the air conditioning people. They did put an air conditioner into this house. After the air conditioning installers had been there, they'd moved the insulation out of the roof so that they get their ducts in. Of course, that showed up very badly on the infrared image on a hot day. These are the sorts of real-world challenges that we have if we're going to try and address climate change. Even if we build very good buildings, do they comply to code? How good is the quality of the workmanship, etc.? Perhaps I'll move fairly quickly over this because I know I'm standing between you and Muriel Watt speaking, so I better keep going. But this is another project through the CRC trying to utilise waste heat off a PV integrated rooftop to drive desiccant cooling, and another project working with solar analytics. If we do have distributed solar, then we're going to have a lot of systems out there, millions of rooftops. How well can we know how they're performing? Solar Analytics is a very interesting company that no doubt many of you know the people involved. A lot of them have been around the PV industry for some time and worked with people here at UNSW and gone through UNSW in many instances. Now looking at monitoring distributed systems and trying to let people know when their system's working well and when it's not working so well. So of course, to do this, I'm going to touch on some work now from from my colleagues, Melindy Kay and others working in energy metrology. If we can know what the weather systems are doing, then we have a better chance of predicting, particularly for distributed energy systems, but also for big central wind turbines and big central solar plants, increasingly important. I will go fairly quickly. More difficult questions can be directed to my colleagues on these slides. And so various projects are being worked on in this space. Anna Bruce and other people in that team, Jesse Copper in particular, looking at all sorts of interesting things with regards to PV performance, the degradation rates, particularly in hot climates. Some issues that are being explored now as PV is rolled out worldwide is what we know about PV performance in places, cooler climates, does that hold in warmer climates? So we need to understand that and how well distributed PV systems perform in comparison to the models. The other thing that Anna and her team are looking at are things like mapping that solar potential, so being able to use smart imaging technology to understand where's the best place in a city, in the country, wherever, to be able to see where's the best place to put PV, and all sorts of good stuff happening there. That NEM widget, I think I'm right in saying, and Anna will correct me if I'm wrong, that NEM widget is relying on data that's come out of these sorts of projects. How do you know how much PV is being generated off rooftops? You need to be able to have some way of tapping into the data, and Anna and her team have been able to do that and let people know how much is coming off distributed rooftops. Policy and markets, I'll let Anna talk to people over drinks, I think. And last but certainly not least, I've slipped in one of Rob Taylor's slides here, so thanks to Rob for that. I've talked a lot about electricity, but of course rooftop systems that utilise solar thermal, high temperature processing heat, all sorts of things that are contributing to climate change. It's a very difficult problem for us to solve, but my feeling is that we need to throw everything that we have to try and solve this problem of climate change. Carbon dioxide, we seem to be drifting in Australia, as Darren alluded to, with regards to our political system. The good news is that research that's happening here at UNSW, Martin talked about it, Stuart talked about it, and the work that I'm reporting here on behalf of my colleagues, all aiming at doing something about climate change. So I want to thank everyone who's in this room, who's been involved with SPRI, and thank you for your contributions, thank you for being here, and thank you.